Okay. Yeah, so our next speaker is Kevin, and he came all a long way from Europe. You're going to talk about Tekton and ArgoCD, which is a very popular tool that we'll use for our cloud native CI and CD. 然后这是我们下一位讲者是 Kevin，那他大老远从那个欧洲跑过来，对，那也是我们邀请过来的讲者。那他等下会介绍就是Tekton 跟 ArgoCD 就是这两个大家可能很常用会一起用来做来 CI/CD 的一个tool。那我们欢迎那个 Kevin。
Yeah, then I'll bounce around. I'll bounce around a little bit between here and there. So yeah, welcome and thank you for coming. I asked Gene how to say good morning, but I already forgot in Chinese. Sorry. Taiwan. Okay. All right. So in this session, we'll talk a little bit about doing kind of next generation-ish CI/CD. So the tools that I'm going to be talking about are Tekton and ArgoCD. So Tekton is technically not a CNCF project. It's part of the CD Foundation, but it's still part of the Linux Foundation. And well, ArgoCD, of course, is part of the CNCF Foundation. So just a clarification. Anyway, so this is kind of how I started doing my continuous delivery, if you will. So I don't know if you recognize this FileZilla, you know. So back in the day, or maybe some people still do it this way. You know, you have on your local machine some files, and you copy them over. You know, it works, but it's not very robust. And if you have issues, then yeah, it becomes very quickly not very enterprise friendly, right? So then we moved on over the years and kind of built our own automation. And so, you know, one of the tools that I was using back then was rsync. So basically, we were already fairly modern in the sense that we were using Git for our development and for our repositories. And so we would check out on a master server the master branch, and then you know, copied it over to multiple servers to have high availability with rsync. But again, you know, like if something goes wrong, it's not very easy to roll back. And so, you know, if you look at the kind of the developer flow, you know, a lot was happening in an inner loop, you know, in terms of improvements for development and everything. So, you know, if you haven't seen this in the inner loop, you kind of have this, you know, you do your coding, you do your building, your packaging, you know, ideally some debugging, maybe some testing on your local machine, and then you'll push your code to a repository, and then, you know, probably we'll create some sort of pull or merge request depending on what tool you're using. And then you end up in this outer loop where you're not necessarily working on your local machine or some cloud IDE or something. You have multiple people, you know, kind of in the process. Maybe they're doing code reviews, and then you'll do your build in a continuous integration server or platform. Maybe you do some security tests and some compliance tests and everything, and then, you know, do some deployments. And so you can see here in this kind of representation, you have these two cute logos, right? So this is for the build. We got our little Tekton logo, a cute tomcat. And then here we have ArgoCD or Argo, which also has some other projects like Argo rollouts. But today we're just going to talk about ArgoCD. And so, yeah, we're going to talk about the outer loop. And yeah, why are we doing this kind of more cloud native CI/CD? You know, we're developing more in distributed architectures these days, so we don't just have one thing that we need to deploy anymore. We have all these different components that all need to be deployed individually, which means that, you know, you need a pipeline for each and a delivery mechanism for each of these projects. So we need a better way to deliver. And so, you know, basically we need a good solution for CI/CD. So just kind of clarifying, CI is the process of, you know, building, testing, maybe security checks and so on, and some sort of release to a testing environment. And then CD is the continuous delivery or continuous deployment. And basically the difference between continuous delivery and deployment is essentially continuous delivery. You have everything automated, so you push your code, you go through a process that builds your artifacts or whatever it is based on the programming language that you're using, and get it ready to deploy to production. It's you can deploy it at any time, but you still have a manual step to actually go to production. And this is what most organizations do, because they're like, well, we're not entirely sure if we want to go directly to production when somebody pushes their code, or when it gets merged at least. But there's organizations out there very mature, when you have really good testing in place, really good automation, where they're really continuously deploying automatically. And so that's something where you need tools to be able to do that. And so those are some of the tools that we're looking at today. You can still do the manual part too. So just to clarify, if I don't say that at the end, both tools allow you to do either. So we're going to do, I'm going to do a little demo of how to do this using a little game that I've built together with my colleagues, and it's this car racing game. And so I need your participation. So hopefully you brought your cell phone and you have some internet network, and then you can play along, because we're basically going to be playing this little game. So there's these two little cars, and so I'll show you a QR code, and then you'll be divided into two teams. So you'll be playing against each other in some way. And then we're going to basically create clean energy to power these cars with a windmill. So this is what you're going to be seeing on your phone. You're going to see this windmill, and you have to tap it to make the windmill turn, and that's going to create the energy to make these cars go. Yeah, so maybe real quick showing you how it works. So every time you tap, you create a REST request, and so that's going to send those requests to a Java backend. So I don't know if you're familiar with Java. There's a Java stack called Quarkus, which starts up really fast, has a very small footprint, which you wouldn't necessarily expect from Java. But so if you haven't looked at this, Quarkus is definitely a really cool stack. But anyway, so that's what we built the game with. And so every time there's an event, so you tap, it goes into a Kafka, and then on my dashboard, I'll see, I'll ingest those results, and that's how we're going to power the cars. So let's try it, and I hope this QR code works. Let me know. You should see like some little car spinning maybe that says waiting for game. Somebody can confirm that this is working. It works? Okay, all right, good. So if everybody's done scanning the QR code, then I'll go to the dashboard. So we've got here our game running. So this is running on a Kubernetes cluster, of course. And I think there are 5 replicas running right now. So in my case, I have an OpenShift, so it's an implementation of Kubernetes. And so here we have our game, and so we can see there's 5 pods. So that's how we have our high availability. So if everybody's ready, and I'm going to hit refresh here, and we'll see that that we have some players. So we have 11 people in team 1 and 12 in team 2. It doesn't matter. It's just the average of all the players together. So definitely play, because otherwise you're dragging down the average for everybody else. So if you're ready, you start tapping. Okay. So 3, 2, 1. Okay. So the faster you tap. So team 1 is definitely in the lead. If team 2 will give you a little hint, tap with multiple fingers, it's going to go faster. All right, team 1 is, wow, much faster. And there comes team 2. All right, good job. So we have, actually the fastest person was on team 2. We've got somebody who had the username Rosenman. Who was that? Let's see. Nice. Yeah, so you're very good at with the tapping. And then on team 1, we had somebody with DG Rolamo. I don't know. These are just like random names. So I don't know. Who was DG Rolamo? The champion of team 1. Well, So good job, Team 1, for winning. But don't worry, Team 2, you get a chance to play again. Because why am I showing this game? Of course, now I'm going to release a new version, and we're going to use the 2 projects that we've talked about, well, that I'm going to talk about. So let's jump into that a little bit more. So what if we added a new feature to this game, right? And so you can kind of already see a little teaser for what this new feature is going to be. So instead of tapping the phone, we're going to make it a little more realistic. To power our windmill, we're going to shake our phone. So we're going to use the accelerometer of the phone. So we're going to release that new feature. But before I do that, let's talk a little bit about a story, right? So what if I'm going to add a new feature? This is how I like to do it as a developer, right? So I work really hard during the week, and then Friday afternoon, I'm like, all right, feature is done. Oops, deploy my code to production. It's gonna work. Trust me, no worries. And then, yeah, you know how it works, right? So then at 4 in the morning on Saturday morning, there's issues, and then everybody gets called and whatever. So we don't want that, right? We want a nice process where we can deploy, and even if it is Friday nights, and I put my ops in that position again, that it works in a good way. So if we go back to the developer flow, we want me to do my coding and developing and testing and whatever more, and to have that automated, that nice cycle of automation with some tools. So we want to use cloud native CI/CD, of course, right? We're in the KCD group here in the Kubernetes community, the Cloud Native Computing Foundation group. So I don't have to explain necessarily what cloud native is, I think. But maybe why do we want to use cloud native CI/CD? Well, actually, it makes sense, and especially if we're using things like serverless, we can declare how we want to use continuous integration in the same way that we declare, how we want our environment to be defined in Kubernetes, right? So typically with YAMLs. And so you can do the same thing with these tools, with Tekton and ArgoCD. So you can define exactly, this is what I want my pipeline to be. This is how I want each task to run. So whether it's a git clone or a build of my artifact or whatever, but run those only when I want to run my pipeline. So scale up a container, do the work, and then scale it back down, and only use the resources that I need in that moment. And I have it all defined, of course, in YAML, so I can reuse it. Everybody can see what I'm doing. And that's the idea behind Cloud Native CI/CD. So a project that does that pretty well is Tekton. So Tekton is, well, it's of course an open source project. It's part of the CD Foundation. So like I said, it's part of the Linux Foundation. And so it's a collaboration of different companies. So, of course, we have Red Hat, but we also have, there's Google, CloudBees, so the people behind Jenkins, IBM, and so on and so forth that all work on Tekton. So the idea behind Tekton, some concepts are steps and tasks. So a task is basically a group of tests that you run in a particular container. So a task can be, I guess tests can be like, hey, do a git clone or do Maven test or something, and then you can group some of those together inside a task, and that's a single unit of deployment in Tekton. And so then you have a set of tasks that you define in a pipeline to say, okay, I want a task that does the git clone, then that container can go away. I can move on to running the tests and doing the builds, and then those can go away. I can do some security scans. I can build a container, push it to registry, and whatever more. So that's all you define in a pipeline. And then of course you have the custom. So those are custom resources in Kubernetes, and then if you then have the actual implementation, because this is the definition of this is how I'd like the things to run, and then you have the task run and the pipeline run that are the actual implementation that's going to kick off the process, that's going to create the containers to run these processes. So just a little bit of background. Does anybody know the project Knative? So Knative is another CNCF project to do serverless with containers. It's a really cool project. So Tekton was actually part of Knative, but then they spun it out into its own project because it was kind of, a little bit more mature at the time, and it actually can work independently from Knative, but it does use Knative for the serverless scaling. So FYI. So this is an example of a pipeline. Of course, Kubernetes, so we have to show some YAML, right? So in this case, you have this custom resource, which is the pipeline, and then you can see there's a set of tasks, and then you define the different tasks. In this case, there's only one. There's a git clone, and you have some parameters that you can pass in so that you can reuse the tasks. So every project probably has a git clone, so it doesn't make sense to create a new, YAML with a task for that. So if we can reuse it, and then as a parameter pass in the URL for your Git repository, so you can reuse tasks across different pipelines. And then the workspace is another important concept in Tekton. That's how you maintain state between different steps and different tasks, so that when you do your git clone and that container goes away, well, of course, ideally you still have your source code somewhere for your next step, right? Because otherwise you have to do it all over again. So that's how you maintain state between the different tasks. And then speaking of those tasks, so you actually have a Tekton hub. So I think it's Tekton hub hub.tekton.dev. You can find a whole bunch of tasks, community tasks, that you can just use in your pipeline. So you don't have to invent, build a container image that can do a Maven build or something. So you can probably find a task that already has Maven, and then you maybe pass a parameter to say what kind of Maven task you want to run, as an example. So you have a bunch of tasks already. And then, of course, there's a CLI, too, so you can automate and kick off pipelines and everything. So that's Tekton, so for the CI part, so for the continuous integration. But then we also want to automate how to deploy our applications, of course. And so we want to use GitOps for that. So for those that aren't familiar with GitOps, as the name already says, of course, Git is used in GitOps. So basically you use Git as a single source of truth, not just for your application code, but also for all your definitions, your configurations of how your application should be deployed. But not limited to that. You can actually define exactly how you want your cluster to be configured. Like let's say probably YAML, maybe JSON, but probably YAML in Kubernetes, and you store it in Git, and that's your single source of truth, where you're going to define exactly your desired state of your cluster, of how you should deploy your application, how many replicas it should be using, and so on and so forth. So you know exactly who changed something, you know exactly when they changed it, and so you have exactly the audit trail of what happened. So you can use Git as a single source of truth, treat everything as code, not just your code, but also your entire environment. And then you can use the operations through the Git flow that you're using for your application. So you can use merge request, pull requests. Somebody can review the changes, and then you can push them. And then the GitOps engine will notice, hey, there's a change in your desired state. Let's make sure that it matches with what's actually on your cluster, and it can automatically mitigate that. Or you can say, I want to have a little button that says, okay, you can go ahead and sync my desired state to be what's on my cluster. Vice versa, that also means that if somebody goes into your environment, makes some changes that were not defined, your GitOps engine will notice that and say, hey, this does not match your desired state, so we can automatically fix it, override whatever somebody was trying to do, kind of going around your Git flow, Or again, you can have a manual way to do that and just get a notification saying, hey, Kevin went into this Kubernetes cluster, he changed some configuration, he made the amount of pods smaller or something because he thought there was less requests or something. But he shouldn't do it that way. He should define, like, here's the change that I want to make. Somebody can actually look at it and see what they've what I've been wanting to do. So now the difference between CI and CI/CD and GitOps then, well, CI/CD, you have kind of a one-way street, right? So you have you can still define your desired state. You go through your pipeline, through your tasks, and then you can deploy your application. But that's it. The idea with GitOps is that you have this continuous flow of defining your desired state, seeing what your cluster state is, and then observe it, take some action, and then that's going to continuously happen. So if somebody changes something on a cluster, GitOps will take action. Whereas with CI/CD, if it gets deployed and somebody makes a change, then the CI/CD engine doesn't know what's going on. So you need kind of a little bit of both, because GitOps is not going to do your build of your application. It's not going to run through your tests. It just defines your desired state of what should be on the cluster. So once I've built my container or whatever and I push it, then I can define, here's where to find my container image, and now this is the container image I want to use in my environment, and then GitOps can take that. So you need a little bit of both, and that's why we're talking about both Tekton and ArgoCD. And I'll get to the ArgoCD part. But let's deploy our new feature, of course, in this kind of modern automated GitOps way. So I'm going to do some very complicated coding here. So be ready for this? So I need to go to my other screen here. So I have my Git repository. And so I have two projects here. I have the Quinoa wind turbine. That's where my Java code is in with the game. And then I have the Quinoa wind turbine manifests. And that's where I have all the manifests, the Kubernetes manifests that set the state for my application. So just to give you a quick look. So here I have, just some very basic Kubernetes resources. So I have a deployment, I have a route, which is, like an OpenShift concept for ingress, and a service, and then, a customization file. And in my customization file, I have the image that I'm going to push once I've created my new application. When I've pushed my code, I'll build a container image. And then here's the definition of that. And there's a digest to look at the exact tag that I've pushed. And so what's going to happen is I'm going to build my code. I'm going to push my container image. And then I'm going to update this value with the new value of my container image. And by changing that, I'm changing the desired state of my cluster. And that's how GitOps is going to notice that there's a change. So let me do that real quick. So I'm not going to go here. I need to go to my actual code. Back one more time. All right, so here's my my development that I'm going to do, one-handed. So I'm going to go to, it's not scripts, it's source, I believe. I have to remember where it is now. Main, web UI, source, config. I'm going to edit my file. I'm doing my development right in GitHub. And I'm going to set this flag to true. So that's going to enable the shaking, and then this to false, because of course I've already made this code change. It's just a feature flag. Okay, so I'm going to commit my changes. Yeah, it's a little hard to type. Can you hear me with this? Yes. All right. So we'll say enable shaking. And I'm going to commit straight to my main branch. No code reviews or anything. YOLO! All right, so now I've made my code change, and I have a webhook that calls my pipeline. So I'll show you my pipeline. So in this case, I have it integrated in OpenShift, but you can use Tekton in any Kubernetes. So it's it's of course a standalone project. is just integrated into OpenShift here. So you can see my pipeline. So with the definition here, so as I showed you earlier, right? So there's the pipeline, and then different tasks and whatever more. And then here's the pipeline run, so the actual implementation of the pipeline. And you can see it is doing a git clone. Well, it did the git clone. Now it's doing the build of the source code. Then it's going to use Builda, which is a tool to build container images. And then it's going to push it to a Quay repository. So there's quay.io where you're going to be able to find it. And then once that's done, it's going to update the manifest of that other project. And then once that's done, our ArgoCD, which is an implementation of GitOps, is going to pick up those changes and deploy them. So let's go take a look at that. So I have here my, my GitOps engine. And, well, some certificate. Let's just accept the risk. Sure, why not? And I'm going to log in. So this is me giving permissions to OpenShift because, again, it's running via OpenShift. And here we have the definition of my cluster, right? So in those manifests, remember how I showed you there was a deployment and a route and a service? So you see those here defined. And so based on the service, it's going to set up some resources. Based on the deployment, there's some replica sets, and then here are those 5 pods that we see running. So if we go back to our pipeline, we can see that it's doing the container build right now. We can look at the logs and keep an eye on that because, you know, of course, in our tasks we can follow what's going on. And then we can see that successfully tagged our image, and this is the new digest that it's created. And so then it'll update our manifest with that digest. So let's take a look here at our pipeline run. Okay, so now it's doing that. So it's doing a git clone of our manifest, and then it's going to update the manifest with the new version. So let's take a look and see. Repositories, quinoa, wind turbine manifests. And we can see updated now. So it just happened. My Tekton bot image digest updated. So now we can see that our customization file has been updated to a new version just now, right? So just and so now if we go back to ArgoCD, I'll make it refresh so it goes a little faster. You can see it says, "Oh, you're out of sync." So a new your desired state doesn't match with what's on the cluster. So let's make sure we fix that. So you can see here that it's spinning, and you can see some more pods being created. So it's rolling out our new feature to my production environment. And so once that's done, we're going to go back to our game, and then hopefully we can see that instead of tapping this time, you're going to be shaking to make the cars go. And it looks like I'm running a little bit out of time, so we'll... what I'll do is I'll go back to the slides, wrap up, and then we'll play the game if that works. So so just to kind of recap what's happened here. So I made my code changes, right? Pushed them to Git. Our CI engine, our Tekton, picked up those changes, created containers to run the tasks, then tore those down, and then pushed the image to the image registry. And then in this case, I made the change directly from my Tekton task to create those changes, and then CI/CD, or well, no, CD actually with GitOps noticed the changes and then is going to take action to fix our cluster to our desired state. So ArgoCD is an implementation of the GitOps engine. So let's see if our new version is there. So if everything works well, you can either refresh your browser or rescan the QR code, and then you should see a button that says Enable Shaking. Hopefully you see that, and just tap on that button. And if you're an iPhone, I think you have to give permission to be able to shake. And let's try it. So I'm going to refresh our game here. The new version was deployed. Okay, so our players are loading. So we got 11 players in team 1, 16 in team 2. Again, doesn't matter. It's just the average, right? So if everybody's ready, one warning: hold on to your phone. Okay, don't throw it, especially at me. Okay. So 3, 2, 1, go. All right. And I have to take my own picture, of course. Wow. Team 2. Yeah. So, wow, we have team 2. We have somebody with the username. Actually, team 1 had the fastest shaker again. So who's Dorman on team 1? Yeah, you're very good at shaking your. And then team 2, the fastest one was Golic. All right, very good with with the phone shaking. So hopefully I gave you an idea of how to deploy a new feature automatically with Tekton integrated with ArgoCD to automate your delivery. So that's it. So just a quick, if you want to play around with OpenShift, you can get a free sandbox environment. So you go to developers.redhat.com, you create a free account, and then you have your, you can play around with OpenShift. It has Tekton built in. I'm not 100% sure if it has ArgoCD. It could, but you can use also an external ArgoCD, or you can deploy it on it. And then if you want to learn more about GitOps, this is a free ebook that that my teammates wrote, so you can download it for free through the Red Hat Developers Program. And yeah, some more developers. Here's the slides for this presentation. So if you would like to download the slides, you should be able to find them here. And I'll give you a second if anybody. Sorry, I'm a. Oh, okay. All right, and then that's it. So thank you, and if you have any questions, yeah. All right. I'm assuming that you were asking if anybody has questions, but yeah.
So his question is, can you only use Tekton on a Kubernetes environment?
Yeah, there are other projects, so you don't necessarily need to use Tekton if you want to use ArgoCD or GitOps. So you can use another continuous integration tool. You can even use Jenkins on Kubernetes. The thing with like a tool like Jenkins is that you have to deploy an entire server, and then you need to install plugins, and you need to maintain that. And typically, that's like a very dedicated team. Tekton is simpler in the sense that you just kind of define how you want to run your pipelines, but there's no server to maintain or anything, because it's just, as you kick off a pipeline run, it's just going to start up those tasks. But, there's other projects out there, Spinnaker and, a bunch of other ones. And so you can use those too. You're not tied to just using Tekton. Yeah.
Oh, sorry. I think his question is, can you only use Tekton on Kubernetes?
Oh, okay.
Yeah, so
yeah. Yeah, so you do have to use Kubernetes, I think, because it uses custom resources, and to be able to use the serverless capabilities of well, in this case, containers orchestrated by Kubernetes. Yeah, so you do need Kubernetes.
Hi, I see your demo, which is the ArgoCD on the OpenShift. So is the two different products are integrated together, or it's just a plugin in the in your OpenShift? Thank you.
So, I mean, he wanted to ask if it's integrated.
Yeah. So they are two separate projects. In this case, yeah, on my OpenShift instance, so basically you have I have them deployed via operators, right? So there's you can see here there's some operators installed. So in this case, you see Red Hat OpenShift GitOps, which is a supported version of ArgoCD. So that's how I have that component installed, and then same with Red Hat OpenShift Pipelines, which is the implementation of Tekton in OpenShift. But you can also install, and I can show you here in the operator hub, which is where you find different things that you can install in Kubernetes using the operator framework. If you want to use just Tekton, well, there should be a Tekton operator, but I don't see it. But there's the Red Hat OpenShift pipelines in any case in OpenShift. But you can also go just to tekton.dev, and then you can find how to install it. And then same with GitOps. So there are two separate projects. I'm using them together because it makes sense that for my application build, I use a continuous integration tool. So I like to use Tekton for that. And then for the automated deployment, I use the ArgoCD. But there's also like FluxCD or something. So there's different projects out there as well. I hope that answers your question.
直接讲好了，直接讲。有点小声。
I'm wondering how do you handle a multi-stage deployment in ArgoCD? Like, what is the recommendation way?
I'll use this microphone. So multi-stage deployments, as in there's multiple components to your application that you're deploying. So one thing that you could do with ArgoCD with GitOps is you can use sync waves, and so you can define first deploy this component or these elements. And only once they've been deployed, then deploy the next component. So for example, if maybe a simplified example, but let's say that I want to deploy an application that also has a database. I first want to deploy the database, or maybe before that, even the operator, and then the database that's deployed by the operator, and then wait, and then so you can set in the wave that's the first wave or the second wave, and then the third wave is to deploy the application, and then a fourth wave might be to create some test tools on Kubernetes. So yeah, so hopefully that answers your question a little bit. Okay.
So that's thanks, Kevin, again.
Thank you. Shishir? Okay.